Hi guys, I hope that you're all doing well. In today's lesson, we'll do parallel lines. So parallel lines and perpendicular lines are worth a lot of marks in exams. In this video, I'll only focus on parallel lines. I'll introduce them and I'll let you know different ways they'll test you about parallel lines. We'll do perpendicular lines in the following video so that I don't overwhelm you in this lesson. So what are parallel lines? Parallel lines are lines that are always the same distance apart and never meet or cross each other. For example, if you have, let's say, this line and that line, they usually show you the two lines are parallel by using those two things. Or they usually say something like, let's say we have those two lines, let's say this is line A and that is line B. They might give you a statement and say line A and B are parallel. So in a diagram that you're given, you may use those two things to prove that the two lines are parallel. Okay, now let's move back to these lines. You guys can clearly see that this line and that line are not the same length. These lines are always the same distance apart. Therefore, they always have the same gradient. Okay, this is the most important thing about parallel lines. You should know that they always have the same gradient. So in mathematics or in geometry, we use the symbol, this symbol, to show that two lines are parallel. For example, we might say line AB is parallel to BC by using this symbol. And on diagrams, for example, if you have this line and that line, they might use these two matching arrows to show that they run in the same direction, to show that these two lines are parallel. And remember, parallel lines always have the same gradient. Now let's start with the first example. We have, given the points A, B, C, and D, prove that AB is parallel to CD. Okay, remember, parallel lines always have the same gradient. So to prove that these two lines are parallel, you have to find the gradient of AB and the gradient of CD. And if they are equal, if they have the same gradient, then these two lines are parallel. Now let's remind ourselves of the gradient formula. We have m is equal to y2 minus y1 all over x2 minus x1. So they said AB, okay? So let's write A. The coordinates of A are -2 and 1. And the coordinates of B are 2 and 5. So we can label A as 0.1 and B as 0.2. This -2 is your x and that 1 is your y. They are all under 0.1, so this is x1 and y1. So for B, we have 2, which is your x, and your 5, which is your y. That is x2 and y2. Now let's substitute. We have m is equal to y2. Where's y2? There it is, it's 5. 5 minus y1, which is 1, all over x2. Where's x2? There it is, it's 2 minus x1, which is -2. So you have to put this in a bracket, -2. So when you punch this in your calculator, you'll get an answer of 1. So the gradient of AB is equal to 1. Let's find the gradient of CD. What are the coordinates of C? C, we have 1 and -3. For D, we have 5 and 1. Now let's find the gradient of C and D. Let's rewrite our formula. Y is equal to, M is equal to y2 minus y1 all over x2 minus x1. Okay, now let's label our points so that we don't make any mistakes when substituting. You can use C as 0.1 and D as 0.2. We have 1 here, which is our x, and -3, which is our y. We have 5, which is your x, and 1, which is your y. So these are under 0.1, so this is x1 and y1, that is x2 and y2. Now let's substitute. We have m is equal to y2, y2 is 1. We have 1 minus y1, which is -3, it should be in a bracket all over. You have x2, which is 5 minus x1, which is 1. So when you punch this in your calculator, your gradient should be 1. So we have the gradient of AB, right, which is 1. We can specify this by writing your small m, then AB is equal to 1. Okay, let me erase that. Here we can specify it's the gradient of CD. So we specify this by writing our small m, CD is equal to 1. Now let's state our conclusion. We have the gradient of AB is equal to 1 and the gradient of CD is equal to 1. So gradient of AB is equal to the gradient of CD. You have now proven that these two lines are parallel as they have the same gradient. So just remember, no matter how they phrase this, remember parallel lines always have the same gradient. So if they've given you these 4 points, you have to find the gradient of the first 2 points, then the last 2 points, provided that they've specified the pairs. Here you have AB and you have CD. You found the gradient of AB, you found the gradient of CD, and they are equal, which means they are parallel lines. You've proven that. So you can also say AB is parallel to CD. This video is proudly brought to you by McDonald's. Download the McDonald's app today and start earning points every time you order your favorite meals. The more points you collect, the closer you get to exciting rewards like free burgers, desserts, drinks, and more. Simply order through the app, collect points, and redeem them for delicious treats once you've reached the required threshold. Get the McDonald's app now for more information and start enjoying rewards with every bite. Now let's try the second way in which you'll be tested on parallel lines. The second way in which they'll ask you about parallel lines is that they might ask you to find the equation. Okay, let's try this. Find the equation of a line parallel to y is equal to 2x minus 5 that passes through. We have a point 1 and 4. So whenever you deal with parallel lines, just remember one thing: they always have the same gradient. No matter what happens, you can write this for yourself in an exam. Just remember that they always have the same gradient. And when you're given a question, if it looks funny or if it sounds a bit complicated, just relax, reread the question as many times as you can. And when you see this for the first time, it'll probably look difficult, but it's honestly such an easy method. You just need to be open-minded and to really focus. So what are you given here? You have find the equation of a line parallel to, you know already that you have to find an equation, right? Which is obviously a straight line. Remember, y is equal to mx plus c. You have to find the equation of a line that is parallel to y is equal to 2x minus 5. So you're given that equation, okay, that passes through 1 and 4. That is obviously your point. Line of equation of a line, what is your straight line formula? Y is equal to mx plus c. Okay, so we have to find this equation, okay, our straight line formula. What do we have so far? We have y is equal to 2x minus 5. And they said that it's parallel. When you look at this straight line equation, you have 2 as your m. And remember, this is your gradient. So the line that we'll find is parallel to line y is equal to 2x minus 5. They just didn't say AB parallel to BC, but we're actually dealing with 2 lines here. So from here, we can already know that we have the same gradient. We already know that we have the same gradient. We can substitute that gradient, which is 2. So you can say m is equal to 2 because it's parallel. So this will be y is equal to, that m is 2. We have x plus c. What's next? We have a point. And remember, we did straight lines in the previous video. I said you can substitute any of the points. In this case, you only have 1 point. You have 1 and 4. So this one is your x and that 4 is your y. Where we see y, we have to substitute 4. Where we see x, you have to substitute 1. So this will be, what is your y? 4 is equal to 2 times, what is your x? 1 plus c. Remember, it should always be in a bracket. Now let's solve for c. We have 4 is equal to 2 times 1, which is 2 plus c. Let's take this to that side. This will be 4. This is positive 2. It crosses the equal sign. Minus 2 is equal to c. 4 minus 2 is 2 is equal to c. Therefore, c is equal to 2. Now, we had y is equal to 2x plus c. Remember, this isn't complete. We still need to find our c. We calculated our c, so we can write our final answer as y is equal to 2x plus, what is your c? 2. Now let's look at our question. Find the equation of a line parallel to y is equal to 2x minus 5. We already have our solution there. We just solved the equation. This is the line that is parallel to y is equal to 2x minus 5. Now let's try the last variation that includes collinear points. The third way in which they'll ask you about parallel lines, it'll be a question that includes collinear points. Prove that points A, B, and C lie on a straight line or are collinear. So for A, we have -1 and -1. For B, we have 1 and 3. And for C, we have 4 and 9 as our coordinates. Before we even attempt this question, what are collinear points? Collinear points are points that lie on the exact same straight line. For example, if you have a line, let's say this straight line, and there's another line, let's use a different color from here to there. Let's say they're exactly on that line. Okay, just ignore how off this highlighter is. And let's also use another line on top of those two. This is basically what they're saying. A, B, and C are all straight lines. Okay, they are all here. We have line 1. Let's see, this highlighter is 2. And that funny one is 3. So if they're all straight lines, that means they have the same gradient. Okay, so with collinear points, if they say that they lie on a straight line, if they talk about collinear points, just note that they have the same gradient. And if something has the same gradient, that means that those lines are parallel. So how do you think we'll prove this? A, B, and C are collinear. We could find the midpoint of AB, then find the midpoint of BC. And if the gradients are equal, and there's a common point, which is here we have B, and you also have B there, that means they're collinear. If they have the same gradient, that means they are parallel. Although they didn't specifically say anything about parallel lines, when you see collinear, think about parallel lines or gradients. Okay, so collinear, you have to think about parallel lines as well as gradients. Now let's start by calculating the gradient of the first segment, which is AB. What is our gradient formula? We have M is equal to y2 minus y1, but it's the gradient of AB. So let's specify MAB is equal to y2 minus y1 over x2 minus x1. When you substitute, let's specify. So the gradient of AB is, let's label our coordinates. For A, we have -1 and -1, and for B, we have 1 and 3. This is 0.1, and that is 0.2. That -1 is your x, that -1 is your y. That 1 is your x, and that 3 is your y. So that'll be x1, y1, x2, y2. So we have y2, what's y2? 3. This will be 3 minus y1, which is -1. In a bracket all over, we have x2, which is 1, minus, we have x1, which is -1. It should be in a bracket. So when you punch this in a calculator, your answer should be, the gradient of AB is 2. Now we have the gradient of AB, which is 2. Let's find the gradient of BC. Gradient of AB is 2. Now let's find the gradient of BC. We have y2 minus y1. Let's label our coordinates. We have B, which is 1 and 3, we have C, which is 4 and 9. This is the first point. That's the second point. We have X, Y, that is X, and that is Y. So this is X1, Y1, X2, Y2. Now let's substitute. Here we have Y2. Y2 is 9, followed by a minus. Y1. Y1 is 3. All over, we have X2. X2 is 4, minus X1, which is 1. Punch this in your calculator, and your answer will be 2. So you've done all these workings on your paper, right? I'm just erasing this so that I can make some space. You had the gradient of AB as 2 and the gradient of BC as 2. So when you state a conclusion, we'll say the gradient of AB is equal to the gradient of BC. That's all that you have to do. So those are 3 different ways in which you'll be expected to find the different ways in which you'll be asked about parallel lines. If you guys need more videos and examples on parallel lines, please let me know. But remember, I'll do exam questions so that we can put this knowledge into practice. Thank you for watching. Please like and subscribe. I'll see you in the next video.